I'll be posting this slide deck to D2L, or you'll find it in D2L underneath the previous 3 sets of petroleum geology slides. Dr. Meadow and I had talked, and I'm obviously concerned about just the volume of information, and I wanted to come up with a way to kind of guide you on what I really wanted you to learn, to summarize things, and have you ready for the exam. And Dr. Meadow was gracious enough to say, well, yeah, I'd like to prepare a summary, and he just slimmed down his presentation to what he thought the key points were for you to learn. And you're going to see that I'm going to further slim down some of his key points into what is going to be testable on the exam. In some cases, I'm going to tell you this stuff is important, but we're going to talk about it later in the class that will not be tested on the exam. So this basic idea of the petroleum system is important. Make sure that you understand how it starts with source rock, migration, a trap, and a seal. All of these diagrams are all ways that he used to illustrate this and walked you through this very key principle that the hotter it is, the more likely it is that gas is going to develop. And if it's not to a certain depth, it won't get hot enough at all, and the kerogen will just remain kerogen and not turn into hydrocarbons. So again, all of these pictorials are just giving you the idea of what goes on. 2 concepts I want you to be very versed on are porosity and permeability. They're almost so foundational, they're too simple to test on the exam, because I would hope that everybody has a good sense of that. I'm certainly not going to get into, well, how many millidarcies does it need to be? As far as the unconventional, he's got some slides later in this deck, but this is where you're more drilling into the source rock, and it's done through horizontal drilling and combined with fracking. We'll talk about that more later. So when they go back and they're looking for places where the oil could be, these are the things that they're looking for, are the elements of the petroleum system there. And then if the answer is yes, then it's something to look into. You don't need to worry about this slide. This slide simply says, this is talking about a reservoir that in the earliest days they're drilling wells. That's contributing to the production rise. Then they stop drilling wells and things go down like that. For the most part, in all wells, they produce the greatest earlier in their production, and then they start to decline from there. Don't need to worry about this slide. Don't need to worry about this slide. As far as the whole idea of logging, what I'd like you to have is kind of a big picture. That the most basic is the mud logging. And then they have various options to do it through the open hole and then through the cased well. Wireline, I'd like you to be familiar with that word. That's where they are lowering a string down, and they're doing several different types of tests with sensors. You don't need to worry about that. You don't need to, or knowing what type of tests are doing what, and you don't need to worry about it knowing how to interpret them. For the cores, the key thing is, just like it says, they're the only real reservoir samples. This is the one time where you really get to see what is there, and these are the sorts of things that you get from that. Don't need to worry about this slide nor this slide. This is an interesting slide, but I can tell you that we're going to talk about this a lot more later on in the production slide. So we're going to set the basis of this, and we're going to talk more about it later. So improved oil recovery, this is not a pump jack. A pump jack is still the primary drive. Pump jack is just getting it from the wellbore up to the surface. Really, it's water flooding and then the infill drilling where you're just putting more holes in the ground. Enhanced oil recovery is when you're chemically changing the properties of the oil. And this is where Josh asked the question tonight, well, how does that work? Sometimes it's chemicals to change the nature of the oil so that it moves better. Sometimes it's heat to increase the viscosity, and sometimes the CO2 interacts with the oil to, again, make it flow more easily. Don't need to go too deeply into this, but the idea of the formation drives is an important concept. What is driving it? Gas drive. We looked at water drive, solution drives, and you can see if it's just a solution drive, probably going to get the least oil. Then as you get a gas cap, it gets a little more. If you add gravity in there, even more. So with gravity working for you, even more. And just a pure water drive, like he said, that's an easy one that can get you a lot of oil. So this again talks about primary production. This is up to and including a pump jack. Secondary recovery would be water flooding. And then tertiary, who knows? It depends on the nature of the reservoir. But again, as he pointed out, this is expensive. This is really the key thing to walk away with, just like he said in our lecture tonight. Don't need to worry about this chart. We're going to talk a lot more about casing and cementing later. Don't need to worry about this chart, nor this chart. Decline curve analysis, just know that this is what is, like it says, most useful for mature fields with established production trends, which is for the most part what you'd be looking at. Don't need to worry about this slide, nor this slide, nor this slide, nor this slide, nor this slide. I'm on a roll here. Nor this slide, nor this slide, nor this slide. This slide, yes, you do need to worry about. What, again, if you remember, the key thing is that historically, people are always too optimistic about the amount of oil that they're going to extract. And as we're going to see later in the financial modeling, that's a pretty key point. How much oil I'm going to get out of this thing and how quickly I'm going to get it out is a key decision as to whether or not this well is going to be economic. These are just some quotes that go with that. Nothing to add there. Don't need to worry about this chart. This is a nice chart that explains conventional versus unconventional, so be familiar with this. Incidentally, a single horizontal well can cost from 9 to 25 million. That's absolutely true. They can be extremely expensive, but a lot of the ones in the Permian are being drilled in the $3 million range, so don't think that 9 million is as cheap as it can really be done. Again, this slide is a nice summary of conventional versus unconventional. This is a great map where these are, if you remember, the major shale plays I wanted to be familiar with. I also wanted you to be familiar with the Haynesville shale over here. Shale wells decline more rapidly than do conventional wells, and they tend to be more expensive, although those costs are still coming down. Again, what changed the game? The ability to do the horizontal directional drilling where you're able to put the well bore into the source rock and hold it there was the big technological advancement. Fracking has been around for decades. The idea of slickwater fracking, where they got better at the stages, was more of a natural evolution. But people, real fundamentalists will tell you that wasn't new. Fracking wasn't new. We've been fracking for decades. They got a lot better at it, though. What was really new was horizontal drilling. We're going to talk more about this later. The fracking fluid, I hope you picked up on this in this presentation. When people talk about fracking fluid, 99.2% of it's water. Only less than 1% is a chemical. And as he pointed out to you, those chemicals are not particularly exotic. And then he wound up with the fracking and the earthquakes. The thing I'd like you to remember is it's not so much the earth, or it's not the fracking itself. You didn't put the slide in there. It is the injection wells that seem to be the problem. A diehard industry person will tell you that nothing's been proved. What Dr. Meadows is telling you is, in his opinion as a geologist, it's the injection wells, and that's more the sort of the consensus view. I hope this has been helpful for the geology review. If I were studying for the test, I would just go back and use the review slide deck, and I would make sure I understood the points that I just covered, and you should be good to go. See you Thursday night.